Dear students, you are welcome in this class. This is practical class and we are going to learn estimation of available nitrogen in soil. In the last practical where we did total nitrogen and plant and soil samples, you were very well, you must have clearly understood what is total soil nitrogen and what is available nitrogen. So this available nitrogen is very frequently measured by Subaiya and Asija method, 1956. This method still continues in most of the laboratories in India, where we use potassium permanganate. It is also called as potassium permanganate method to estimate the available nitrogen, or Subaiya and Asija method. In this case, we estimate the readily oxidizable nitrogen plus ammonical nitrogen. In this method, we cannot estimate the nitrate nitrogen. So nitrate nitrogen is not included in the available nitrogen by this method. However, some adjustments were made by Sehrawat, Dr. Sehrawat, and some more scientists to include nitrate also. So if you want to include nitrate, you need to use Devada alloy. Devada alloy contains 3 metals and which reduces nitrate into ammonium. And then again, similarly, ammonium sulfate is formed. So here in Subaiya and Asija method, only ammonical nitrogen and readily oxidizable nitrogen is estimated. Here, organic nitrogen is not included at all. Organic nitrogen is not included at all. The basic principles remain almost the same. So the objective of this exercise is to learn the chemical method for estimation of available nitrogen in soil and some concepts related to available nitrogen in soil. The principle of Subaiya and Asija 1956, they published their paper in Indian Journal, which is published by Indian Institute of Science, Bangalore. They publish one very famous journal. What is its name? One journal published by Indian Institute of Science, Bangalore. Anybody? Anyway, I will tell you in the next class. Alkaline potassium permanganate, KMNO4, liberates the ammonical nitrogen. Why we add potassium permanganate? Because it liberates ammonical nitrogen and hydrolyzes readily oxidizable nitrogen. Nitrogen from organic compounds present in soil. So here, readily oxidizable nitrogen is included. The liberated ammonia is absorbed in boric acid containing mixed indicator. The principle remains same as in case of total nitrogen. The amount of ammonia is calculated by titrating the distillate against standard acid. We can use sulfuric acid. We can also use hydrochloric acid. Any of these can be used. Reagents are KMNO4 potassium permanganate solution, 0.32%. Remember, 0.32%. What can be done? Dissolve 3.2 gram KMNO4 in 250 to 300 ml or milliliter distilled water in a 1 liter volumetric flask, and then make up the volume to 1 liter and mix it. You need to prepare sodium hydroxide solution. You know the role of sodium hydroxide solution. Dissolve 25 gram sodium hydroxide flakes in 250 to 300 ml distilled water. Mix well and make up the volume to 1 liter. It will make your 2.5% sodium hydroxide solution. And some liquid paraffin is required, and also 0.02 normal sulfuric acid. In the last case, you have used 0.1 normal sulfuric acid, which means N/10 sulfuric acid. Here you are using more diluted sulfuric acid, which is 0.02 normal sulfuric acid. It is how many n by 10 it will be? N by 10. Hello, are you there? Is everybody, like if I say this 0.1 normal, 0.1 normal means n by 10. If it is 0.02 normal, how you can express it? If 0.1 normal is n by 10, 0.02 normal is
N by 20, sir.
n by
N by 100, sir.
n by 100.
0.02.
दोबारा करो. All should do it.
N by 50.
N by 50. So this is n by 50. So why this is more diluted than the last case? Because the value or amount of nitrogen was much higher there. Here the amount of nitrogen will be less because we are just calculating very small part, that is maybe 2% of the total nitrogen. So therefore, for more accuracy, if you want more and more accuracy in your results, you should use more diluted solution. More diluted solution. That is the purpose here. Is it clear? Boric acid mix indicator solution, as we prepared in the last case, dissolve 20 gram boric acid in about 700 ml hot water. Transfer the cooled solution to 1 liter volumetric flask containing 200 ml of ethanol and 20 ml of mixed indicator. Mix the content of the flask and add a little 0.02 normal sodium hydroxide solution until the color is pink. Make up the volume and mix the content of the volumetric flask. So this is how you can prepare boric acid mixed indicator solution. How to prepare mixed indicator? Same way, dissolve 0.07 gram of methyl red and 0.01 gram of bromocresol green. These are the two indicators in 100 ml of 95% ethanol. This is not prepared in water. This indicator is prepared in ethanol. Procedure. Here you see the amount of soil is also higher. In total soil nitrogen, you have taken 5 grams soil. Here you are taking 20 grams soil because the nitrogen content is less. So to increase more precision or accuracy, you take larger sample. 20 grams soil in a 500 ml Geldal flask, add 20 ml of distilled water and swirl the Geldal flask gently. At first, you need to add just water. Now add 1 ml of liquid paraffin and a few glass beads. And finally, add 100 ml each of KMNO4 and NOS solution, one after the other. You need to add, and they are ready for distillation. So this is how you are extracting the nitrogen by KMNO4. Distill the content as you have done in case of total nitrogen. There is no difference. Distill the content in Geldal assembly and collect the liberated ammonia in 250 ml Erlenmeyer flask. The name of the conical flask, the normal conical flask name is Erlenmeyer flask because he must have made it. Containing 20 ml of boric acid mixed indicator solution, reagent 5. In the last case, you have taken 25 ml of boric acid, but here you are taking, 25 ml in case of total nitrogen, but now you have taken only 20 ml of boric acid mixed indicator solution. Again, for the reason that nitrogen quantity will be less. Nearly 100 ml of distillate is to be collected in about 30 minutes. So in the last case, you remember it was 150 ml distillate we have waited. When your conical flask or Erlenmeyer flask will have 150 ml of the boric acid solution with ammonia, water, everything. Here you need to stop when it is reaching the 100 ml mark. The color of the distillate is bluish green. same as in case of last, your total nitrogen. Titrate the distillate with 0.02 normal H2SO4 up to the end point when there is change of color. Now, calculations are very simple. As in last case, here you see available nitrogen kg per hectare. You can directly make this formula. ml of H2SO4 in the sample, how much has been used, minus ml in blank, and multiplied by 0.02. This is the normality of the solution. So up to this, your milligram is there. Multiply by 14, your milliequivalent is there. Up to 0.02 is your milliequivalent. Milliequivalent multiplied by 14, equivalent weight of nitrogen. Up to this is milligram. Convert into gram, 10 to the power -3, and you divide by the weight of the sample. Weight of the sample, and multiply by 2.2 into 10 to the power 6, the weight of the soil. And if you cannot remember all these things, you can simply take ml of H2SO4 in the sample minus ml H2SO4 used for blank, multiplied by 31.36. This is the factor. It was calculated by our teacher, Dr. Rajendra Prasad. He said you get 2 reading multiplied by 31.36, you will get the available nitrogen kg per hectare. But conditions remain the same, that you are using sulfuric acid, which has 0.02 normality, and the sample weight is 20. If you change these values, the result will change automatically. So therefore, it is better to remember the formula, complete understanding. Then you can analyze, you can know the available nitrogen in kg per hectare. Then reactions, friends, these reactions are very, very important. If you write answer to any question just in text, but if it is supported by reactions, some chemical reactions, you will always fetch more marks. What I suggest all of you, that in the first exercise as well as in this exercise, you have number of equations. Try to practice them on rough paper. Take rough paper, 2-3 plain papers, and write and correct yourself and learn these reactions. Write these reactions, learn these reactions, and also learn what they are doing and what is happening. So, and also see the role of different reagents or chemicals. So that way you can perfectly answer any question. I repeat, you must write and practice all these reactions, memorize them, learn them, and whenever required, use them. So here, the reactions, because straightway we go to the distillation. We have taken soil sample, we have added some water, then we have added KMnO4 as well as sodium hydroxide. So what is happening there in the Jandal flask before you start the heating? So KMnO4, you can see 2 KMnO4. This is just to balance the reaction. You can put 2 here, plus water, you have added water. And this permanganate ion is produced, plus potassium hydroxide, 2 KOH, plus 3 O. This O is very, very important. This is nascent oxygen or Navjat oxygen. Nascent, recently born. Nascent oxygen is produced in alkaline medium provided by NaOH. So NaOH is helping in the production of nascent oxygen in this reaction. And Mn4 is permanganate ion. So permanganate ion is produced and nascent oxygen is also produced. Now you have readily oxidizable nitrogen or potentially mineralizable nitrogen here. So formula is RCHNH2COH, like in last case, and then plus O. This is nascent oxygen. So it oxidizes this NH2. It oxidizes NH2 and it is converted into NH4. So you can see this NH4 is formed, and then this NH4 can be converted into ammonia. When you start heating, it will be ammonia and H ion in alkaline medium provided by NaOH. Distillation is continuing. then ammonia moves with the water. Initially, it will escape as ammonia, but water vapors are also there. Both are going together through the same tube to the reaching to the boric acid mixed indicator. So during this period, they are also condensed. And this ammonium hydroxide reaches the boric acid, react with boric acid and forms ammonium borate. Ammonium borate, or it should be ammonium tetraborate. NH4 thrice borate. I think it should be. There is some problem here in the formula. I will correct it. You can take it. This is ammonium tetraborate, and then titration. Ammonium borate, sulfuric acid, or HCl is HCl रख सकते हो. If it is HCl, ammonium sulfate and boric acid. So now change of color is pink color. The change of color follows the same pattern as in case of total nitrogen. Now, there are certain limitations. The main limitation is that this method cannot determine the nitrate nitrogen, which is part of the mineral nitrogen or available nitrogen, readily oxidizable nitrogen. So, but this method does not include the nitrate. That is the limitation of this method. So what can be done? Sarawak and Burford, 1982, because usual distillation of the solution with alkaline KMnO4 using this method. Addition of Dewarda alloy. What Dewarda alloy? Only 1.5 gram per sample have good recoveries of available nitrogen, including nitrate and nitrite. So what is Dewarda alloy? It is a powder of metals, metallic powders. 3 metals are there: aluminium, 44 to 46%. This is composition of Dewarda alloy, which is largely dominated by this copper. You see, copper is 49 to 51%, aluminium 44 to 46%, and zinc is only 4 to 6%. It acts as a reducing agent. These metals reduce the nitrate to ammonium form, ammonical form, and help reducing the ammonium and nitrite to ammonia, which can be accumulated in the boric acid mix indicator. So little modification can be made in this method to recover the all kind of available nitrogen. Now, role and importance continues when a solution of nitrate ions is mixed with aqueous sodium hydroxide, means alkaline medium. Adding Dewarda alloy and heating the mixture gently, it liberates the ammonia. And this Dewarda alloy is also used when you are measuring this only ammonical nitrogen and nitrate nitrogen separately. So then that method uses Dewarda alloy and magnesium oxide. After distillation of ammonia, the available nitrogen is determined by titration with acid. So now you will recover the nitrate also. And you can see how the reaction happens. Take one case of aluminium, nitrate plus aluminium plus hydroxyl ions and water, and ammonia is produced, plus 8 AlOH4. So this aluminium is part of Dewarda alloy. Similarly, zinc and copper can also reduce the nitrate or nitrite. It is named for Italian chemist Arturo Dewarda, who synthesized it at the end of the 19th century. Means Dewarda alloy was made by Dewarda. So friends, this completes your exercise, determination of available nitrogen in soil. If you have any question, any doubt, anything in your mind, you can ask me, and this will end your practical and class today. And so you can open your videos and I can finish the class. Now this is the time for your questions. If you have any question, you can ask. And this is, if you know exercise number 1, total nitrogen, you will not find much difficulty in this exercise. And the name of the journal is Current Science. Have you heard this Current Science? Have you heard it? No, not. Current Science is very highly reputed magazine from our country, which has published very good papers over years. Maybe it started in 1950. somewhere, and it has very high standards. So students can also make attempt to publish their papers in current science, particularly those who are having seminars. Any student having seminar, you need to make a presentation in the seminar, PowerPoint presentation. Then you have to produce a write-up on your topic. And by that time, you will have very good knowledge of the subject. And you know the strength and weaknesses of that subject. You understand the subject in much detail. And you also know what can be done in this subject. So that way you can think of writing a review paper. Finally, it will be 5-6 pages review paper published. But any student interested can make an attempt to publish your seminar write-up as a paper. It is possible if you spend time and collect literature and write. So thank you very much. But before that, your questions are welcome.